We've got our aluminum chucked up. First thing I'm going to do is just go ahead and just skin the OD of this round. The reason I'm doing this is because I'm actually going to take it out before we part the retainer nut off. I'm going to take this out. We're going to go to the mill the notches in it for the spanner wrench, and then we'll come back to the lathe here and then part it off. And then that way, whenever I take it out, chuck it, it's going to be true with the machined area that we already machined. And then especially once we put it back in here, we should be trued up within 1 or 2 thousandths of the area that we previously machined. This is just, you know, the factory extruded OD. I can tell it's not perfectly round, so I just want to make a nice round journal on it for chucking purposes. I'm just going to take 10 thousandths. Let's see if that cleans it up. Change our feed. I have no idea what grade this aluminum is. This is just something that Rich provided with his job for me to use, so that's what we're going to use here. That may not be that's supposed to be an aluminum insert, but it's pretty stringy. So I may end up swapping that out and seeing if we got something that'll work a little bit better. Getting caught in there behind it, rubbing it, but this is just fine. We're just cleaning it up. That's all we need right there. All right, so on our original nut right here, the bore right there is 1.575, so we'll just match that. And what I've decided to do, because of work holding, you've got this chamfer that's molded in. This is a molded piece right here, but we're going to machine it. So anyway, you got this bevel on the back side there. It's going to be easier to machine that in the lathe, how it's set up right now, and then go to the mill. And instead of chucking it like I was planning on doing it, I think we could just hold it flat down to a fixture plate with a couple of clamps on it like this, and just use an end mill to mill that slot across there. I think that's the simplest way to get that done. So that way we don't have to worry about coming back to the lathe and holding it, messing up the threads to machine that bevel in there. Yeah, it's leaving a nice finish in there. Using my solid rock machine boring bar that Steve Barton made for me. Just use our telescope gauge and our mic to land on our size. I don't think that bore is super critical, but we'll just get it 1.575. So we got 5, 10, 11, 12 and a half thousandths come out of that. Use a little bit more of this anchor lube here to see if we can get a nice little finish on that. $10, $11, $12 and a half. Yeah, it's got a nice finish in there. The anchor lube does pretty good on aluminum as well, as I've been showing. All right, 575 looks like about a half a thou over 575 and a half. That'll work. All right, 45-degree angle. We're gonna touch off the corner and take 250 thousandths. Get this set on 0 right here. The hat might be blocking you. Just touch that corner right there. Be quick. That's just 50 thousandths there. Just doing a visual, making sure we didn't go too big. Should be right. Finished cut. Just comparing it new to the original there. It looks good. All right, cross slide set to 0, 0 on our DRO. We'll come in here and touch off with our tool, with the compound. All right, there's our touch. Get our 0 set here. Okay, let's do it. Let's make our scratch pass and check our thread pitch. This one we should be running, we should be able to run some RPM. I got it set at 620 on the headstock here. Here's our screw pitch gauge. All right, and we are good to go. So we're ready to thread. All right, I'm going to check you here. I've got some of this Tap Magic for aluminum, so I'm going to use a little bit of that for some lubricant there, and we can use it for our threading as well. Now that we're sneaking up on our finish. I did deburr the threads, by the way. Yeah, we still got a little ways to go, but we're getting close. Still a little bit further to go. All right, let's give it a check. I think we hit our mark there. Just put a little bit more of that lube on. That feels good. Let's get it up in there. It's probably going to be threaded up into somewhere about that area there. Very little wiggle on that, so it's got a good precision fit. You could stand for a couple thousandths clearance on that, but I think I want to leave it alone. Just leave it right where it's at. So I went a total of 5 thousandths deeper on the compound than when I was threading the ID there. So threading the OD and getting these two to match, we went a total of 43 thousandths on the compound, where when we did the ID, we went exactly 37.5 thousandths and stopped there. But that's a good fit. I like that. I think that's going to work really good. I thought I would check something, so I got it screwed back up on there. Let's go just till it tightens up. We'll see how straight and concentric I got the threads to the bore in this bearing right here. That's looking pretty good. I don't want to spin it that fast. Let me slow it down. We can turn it on. Wow, pretty darn close. If I might say myself, I might see 2 or 3 thousandths TIR inside that bearing bore there. So we did good on our indicating. We had it right where we needed it to match up with that existing bore. Curiosity was getting to me. I wanted to see what the TIR is on that bearing there after it being screwed onto the threads. I had it said that I think it's going to be within 2 to 3 thousandths. So let's see. So it looks like right at 2.5 to 3 thousandths. That makes me happy. That's going to work out real nice. So we're going to go ahead and get this piece parted off there. The only thing I don't like about the order of operation for this is I always like being able to take a piece that I part off and chuck it back up and face it off. And I could do that, but I would need to make some aluminum soft jaws. I don't have any, and I don't want to chuck on these threads and mess them up at all. So we're gonna part it off. I'll use that Tap Magic there to help lubricate the cut, try to get a good finish on it. And if we need to, we'll just lap this thing on some fine grit emery paper once we're done to kind of slick out that face there a little bit. I am gonna part it in there a little ways with a tool. We'll retract. I'm gonna put a chamfer tool in there so we can do a machine chamfer on the threads, and then we'll go back in there with a parting tool to finish it out. And I got this piece of UHMW here that I'll use as a little catch rod whenever it pops off. All right, so here we go. We've got our links set. I have got a 0 here. Let's see, we've got a 0 on the DRO now, so we should be good to go. By the way, that's 3/8 thick on our finish, okay? So, just gonna gauge the power feed, put a little bit of this in there. All right, let's back out. And then get my chamfering tool here because I want to machine the chamfer the corner of those threads. Pretty good. Actually, let me get a file. Okay, I think that'll work right there. Go back in here with our parting tool. Come around here to our 0. Right there. Stop the machine. Let's see how we look here. Okay, it's not bad. It's got a nice smooth feel to it there, so it's not bad at all. I think we can clean that up, and we'll just deburr this manually, use a no-go on the inside. I think we'll be good. We got some 600 grit taped down to this cast iron surface plate. We use that to see if we can just lap us a nicer finish on this. I think that's going to work out pretty good. We've got our part clamped into this fixture plate here using a couple little small hold downs, and then now I'm going to go ahead and get this thing indicated, get the indicated in the center. We need a little more engagement there. Really just looking for this way right there, honestly, because we just want to be in the middle. 0. That's 1 thou. Actually, that's metric. I'm sorry. I am using a metric indicator, but all we're using, it doesn't matter if it's metric or inch on the gauge there. We're just using it for reference on movement is all we're doing. So I think we're pretty good. I'm going to zero out my Y axis here. And we are good to go. All right, well, short of a little bit of deburring right there, this job is finished up. I think our secondary plan on getting this finished up worked out pretty good. All right, I was concerned about marring that surface of that aluminum, but it looks like it worked out pretty good. These are just some little pieces of plastic shim that I had. Set these down where I usually put them so I don't lose them. Let me blow this thing off. There we go. That looks pretty good. I even like the lap finish on there. It's a good alternative way to clean up a face on something that you don't necessarily need or can go back to the machine with easily. So it's just a good way to finish that out. I would have rather it look like that, but that looks good too. Let's go put the piece let's put the housing and the new retainer together for the last time and get this guy finished up. All right, guys, we're going to go ahead and put this together and just get it finished up. It's real simple. So the spindle just bumps in there. It's going to go through that small bearing. And it should, I think it should just bump in there. Let's see. Yeah, just like that. That'll have to be knocked in there a little bit, but just to put it together so you guys can see how it all goes. It's going to be in there just like that. All right, take our new bearing retainer. if you can get it started straight, it might go on there. I'm at sort of a weird angle here trying to do this. There we go. All right. I'm not sure what else goes up in here. I haven't seen the whole, this is all I've seen of this bandsaw. There it is. There it is right there. Just touch the bearing. That's it. I'm happy with it. I think it worked out pretty good. It looks good. And that's exactly what Rich asked for, was to repair this, repair the threads. And this was my idea of a good way to get it repaired. When you've got enough material there, you're not going to affect anything else on the part. Just simply skin it out and rethread it. That's something that I've done many times over the years, especially on, let's say, hydraulic cylinders, hydraulic tubes, where you have a very large head gland, say like a 6-inch head gland or whatever, something like that, that screws into a barrel, and the threads would gall on it, get messed up. I would do basically the same thing as this, just skin that out and rethread the barrel, save the barrel, and then I would machine a new rod gland for it with the threads matching. I would typically go to like a standard size, so say if it was 6-inch, I might go to 6 1/8 or 6 1/4, something like that, you know what I mean? But this right here was just, we wanted minimal removal of the cast iron there, so all we did was just clean up the depth of the thread was all. So that worked out pretty good. That was a pretty good job to do in the manual machines, the manual lathe, some indicating techniques there, and then using our little fixture plate to mill the slot. I enjoyed it. It was a pretty good little project there. So this will get Rich fixed back up so he can get his bandsaw in operation again. So I'll get this packaged up and get it sent back his way. So that is it. We'll give him his material left over and the old piece there so he can have a, I don't know, a souvenir. But hopefully you guys enjoyed watching this project, and I hope to see you again on the next job.